Hello, this is Mr. Finney. I'm going to be doing an Onshape demo for how to sketch, 3D model, blueprint, and share your documents between different collaborators. Feel free to at any time to pause, rewatch, rewind any part of this video so that you can be successful. This is an example of a very basic looking arcade cabinet frame that I'm going to be demonstrating how to 3D model, how to assemble and make a blueprint of. So let me start over from the ground up and show you how to get it going. So right away, clean up your workspace by hiding unnecessary planes. And I'm going to be sketching from the top plane. So have the sketch button up there, click on the plane, reorient your view. The angle iron that I'm going to be replicating is roughly a 1/2 inch long by 1/8 inch wide. So the way I'm going to go about making that is I'm going to grab my rectangle tool and just make a 1/2 inch by 1/2 inch box. I'm going to use the offset tool to offset 2 of the outside edges at 1/8 of an inch. Okay, click to confirm, and then I'm gonna just use the trim tool to trim away the extra pieces. Okay. Now my arcade cabinet frame is going to be 3 inches by 3 inches. The way that I make these dashed lines is I grab the line tool and I press Q to make it a construction line. So the reason why I'm doing these is because I'm going to mirror this one that I've sketched, and so I don't have to model it 4 times. So if you hover over your line till you get this box, that is the midpoint of your line. So these are just kind of a rough length. They're not permanently dimensioned to be anything. I'm just using them to mirror things over. So you need to select a mirror line, and then you can hold down Shift and just drag a box around it and mirror it over there. These points are from when I drew that box, so I'm just going to get rid of those. And then do it again for the other side. So I'm going to extrude these to be 3 inches tall. Okay, the hotkey is Shift E. Okay, we're going to be making new bodies 3 inches tall. There's my brackets. Now I also need a couple pieces of material to attach to these. So I'm going to make a new sketch. Okay, my material is 3 inches by 3 inches. Common thickness of aluminum that we use in machining is 42 thou thick. So I'll just start with that. Okay, so now I need to go to this assembly tab here, and I need to insert parts from the part studio. Okay. So we're going to be using this fastened mate tool in order to attach things together. So just going to do one side so you can kind of see what part is what. I'm going to need to hide some of these things to make my life a little easier once I get started. So I'm going to use the fastened mate. Now the first thing it wants you to do is say to fasten it from what to what. So I'm going to start with this top corner here. I'm going to fasten it to the top corner here. So there's this little origin point that hovers. Just make sure you're not going to the top. You can see how it will change the axis that's going to fasten to. So just watch out for that. Okay, so we got it fastened. I think that we could reorient the axis, flip the primary axis, or you could also just offset it by the thickness of your part there. All right, so we got our material on our frame there. Now, let's see if we can, yeah, here we go. So we can create drawing of assembly 1. But before we do that, what else can we do in here? Can we create sketches in here? No. But before we can do that, what we also want to do is we want to plan for some of these hole locations. So when you go to make these parts, it's really important to not be like, okay, this is carbon fiber, this is angle iron. Machining is going to plan to drill this hole, right? We'll do number 30. So number 30 is 30 seconds, so 3 divided by 32. Also, sorry, 30 seconds. Okay, also known as 1/8, 0.125. Okay, so for example, if machining is like, okay, we're gonna put this hole half a quarter inch in, quarter inch down. What we don't want to do is say, okay, we're both going to drill that hole quarter inch in, quarter inch down. I'll drill the hole in the frame, you drill the hole in the carbon fiber. No, we need to clamp them together and drill those holes at the same time. But in order to plan for where those holes are going to go, we're going to create it on the blueprint. So I'm going to show you how to do that. Okay, so remove. And you can cut that hole through multiple things at the same time, perfectly lined up, right? We sketched those perfectly in line, but you have to include the other part in your merge scope. So I clicked on this and I selected that part and it included that in the cut. I'm just going to quickly do the same over here. Okay, again, including your merge scope, then you have to drag that arrow through the other part. Okay. Now we're going to need to do the same operation on our material. So 1/8 inch hole. The Part Studio might take that as a different size, or a different side rather. No, okay, we're at the right spot. Okay, so I did 1/4 inch down. And let's see, I sketched it from this edge, but that's going to be, okay, 300 thou from the edge. So all these things, right, I'm getting really specific into some of these things, but really all these things are just how are you going to plan to be successful in this, right? If you map all this out, you make a plan for how it's going to be assembled, you're going to create a lot more opportunities for success than if you just clamp it up and start drilling. Okay, so, okay, yeah, that's what I thought. One of our axes was wrong. Okay, well, that's fine. So now we're going to create a drawing of this. And you can select these 4 viewpoints, and it'll automatically give you those 4 perspectives of what you're building. You can change the scale of it as well. Okay, here we go. So you can change the scale of some of these things, right? Obviously it's going to be a giant arcade, 30 by 30 by 30 volume. So you are not going to be making it a 1-to-1 scale, but we have our basic frame here, and now we need to give our fabricators dimensions. So quick tip here, you never apply dimensions to the isometric view. That's not accurate. We know that's a 3 by 3. So you want to apply dimensions to these other locations. Okay, let's give the diameter call out for the hole. Okay, we have this view of our angle iron. We might even be able to put a detailed view in there of just that component. We won't worry too much about that at this point, but you can make more sheets. Okay, so on a second sheet, you could put another object, just one specific view, but larger, so on and so forth. Okay, we want to give dimensions on where these holes are at. It's important to also not have lines like this intersecting on your drawings, not have it get all cluttered up. It's got to be nice and clean so that there's no question about what's what. So you see I'm kind of dragging things around. I'm able to move things as I'm working to make it more clear. Think about how that drawing is going to communicate what you are building and what you're asking for. Okay, some dimensions are just nice to have. Some aren't necessary, right? We can see that this 3-inch sheet goes from edge to edge, right? This drawing is perfectly, precisely accurate to the way that I modeled it. So you can take some things as givens like that. Now, other things, right, we're all still learning at this stage, so you want to just communicate those things as well. So, but you want to give enough dimensions to where somebody can build this. They can find the right materials. They know what they're looking for. Okay, so these are going to be things that are important to being successful. You want to write who drew it. Okay, who are you collaborating on with it? Right, did an instructor approve your drawing? So that would be something where you bring your drawing, you get it printed out, then we verify it, or we could even probably verify it before printing it, but right, you want to give it a title. Don't just ignore these sections down here, fill them in. Use that space for what it's showing you, what it's asking you to create there, because these are going to be the things that you need to look at in industry and know what it is. Okay, so those are the basics of what we're looking for. So your deliverable for this portion is to take the demo that is provided here and create your own blueprint. That's going to be something that I will preface as well as an important part of the process is to follow along and create your own and practice these skills and create your own blueprint just like I've shown you. Okay, this whole video is here. You can rewind, you can fast forward, you can rewatch stuff, you can ask clarifying questions. But ultimately, this is the level of blueprinting that is going to help the arcade project be successful so that we can make good progress on our parts. We can know what we need to be building ahead of time, right? Times in the past, Composites has just oversized materials, right? Okay, so the frame is going to be roughly 16 inches or whatever by 28, just rough numbers here. And then, so Composites oversizes materials, machining accidentally makes it smaller, or there's a slip up there, confusion, and then now your Composites team has lost 2 days worth of work because they spent whole one day prepping the materials, putting them in the oven, next day cutting them to size. Now it doesn't work. So those are the issues that we're trying to get ahead of by having you blueprint out your frames in this manner. So the first step to that is practicing how to do this and getting these skills under your belt to where you feel confident in how you're going to do this. So that is what you're going to be doing and taking away from this demo. So go ahead and rewatch the video, create a frame like this, right? Take it from a sketch to a 3D object with your whole locations, move it into the Part Studio, assemble it together, create a drawing of it, and give it all the dimensions it needs.